So on Friday, we worked on this worksheet right here, and we learned that it's nice to have perfect square quadratic trinomials, right? We learned that it was nice to have perfect square quadratic trinomials. What do I mean by that? If we take a look at number 5 here, it's nice to have a perfect square quadratic trinomial because when you factor it, and if you haven't done number 5, you could jump in and do it right now, follow me on this video. You'd have an x and an x. What times what is 4? That if you combine together is 4. Again, what times what is the c value? That if you combine together is a b value. Well, that would be a positive 2 and a positive 2, right? If you don't need to make a list, you don't have to make a list, right? But anyways, why do we like these perfect square quadratic trinomials? Because you're going to be able to write them as a binomial squared. See how it's the same exact binomial? You could rewrite it as a single binomial, but you square it. And of course, you still have this equals 2. Okay. Now, why do we want this binomial squared? Because now we could just get rid of things by doing the opposite, right? Like, what's the opposite of a square? A square root. So I'm going to get rid of the square by doing a square root. And what I do to one side, I must do to the other. And I need everybody to remember that when you apply a square root in an equation, you must put what in front of your answer? Plus or minus. Okay, so far I have x plus 2 equals, there's no more square, there's no more square root, they eliminated each other, equals plus or minus the square root of 2. So for my final step to get x by itself, I just subtract 2. Now, whenever you have this situation, even if it's a nice number, you want to write this number first, and then the plus or minus whatever second. Okay, so even if this would have been like a 5 or a 9 or a 4, even if it would have been a nice number, you still rewrite this number first and the plus or minus item second. So let's do that. X equals negative 2 plus or minus square root of 2, and that's it, we're done. Now the reason why we're done is because the square root of 2 cannot be simplified. That's as simple as it gets. And you can't really add or subtract square roots with regular numbers, radicals with numbers. So this is why we like having a perfect square quadratic trinomial. The thing is, having a perfect square quadratic trinomial doesn't happen that often. And this is why we learn the completing the square method, okay? So like, what is the completing the square method? Like right here is just practice on how to find that perfect c value, okay? So I think I already did 9, 10, maybe 11 on the first video, so let's do 11. Okay, so how do I find the perfect c value? You guys need to memorize this. This is what we learned on Friday, that your perfect c value will be taking half of b and then multiplying it with itself or squaring it. Okay, so the perfect c value comes from this little tiny formula, b over 2 to the second power. So obviously we have b right here, that's 24. And what would half of b be? 12. And then 12 squared? 144. So that perfect c value that belongs right here is 144. So if I did have x squared plus 24x plus 144, because of this perfect c value, I'll be able to write it as a binomial squared. Okay? So this whole middle section of finding that perfect c value and then rewriting it as a binomial squared was just practice, right? You put the x right here, and what belongs in here? Simply half of b. Half of b belongs right there. So what's 24? Half of it, it's 12. So you're going to put a plus 12 right in there. So if you look at the back of your page, the solution on number 11, they'll give you that perfect c value of 144, and they'll also give you this binomial squared, because that's the whole purpose of getting that perfect c value, to get a binomial squared. Yay? And this method is called completing the square method. Now, it gets a little funky when your b value is not divisible by 2. I hate completing the square, I shouldn't say that, right? But I hate completing the square method when the b value is not divisible by 2. If it's an odd number like that one, it gets really, really ugly. So like number 12, if I wanted to find my perfect c value, well, I'd have to take the b, divide it by 2, and then square it. That's a little formula, right? So my b value is 5. That's going to be ugly. Check it out. 5 divided by 2 squared. Well, what does something squared mean? It means times itself. So 5 halves times 5 halves, what is that? Give me a fraction though here. 5 times 5 is 25. 4 times 4 is 4, right? So the perfect C value is this guy, 25 over 4. So the perfect C value is 25 over 4. That's my perfect C value. That's what's in the back of the page as a solution, I think. Or did they put it as a decimal? No. It's like that? Okay, 25 over 4. They could have written it as a decimal. I don't know. I recommend leaving it as a fraction, right? Especially because when you want to write it as a binomial squared, you're going to put x right here. And again, this piece right here is simply going to be what? Half of b. So b is positive 5. What's half of that?
5.
What's half of 5? It's 5 divided by 2, which is a fraction 5 halves. Now, they might have written it as plus 5 halves, or they actually might have written it as plus 2.5. Either one's acceptable. So yeah, if you write it as a decimal, I'll accept that. That's fine. So the lesson here is if your b value is odd, completing the square is not fun. For example, let's jump down to the last part where it says solve. Okay, it says solve each equation by completing the square. But as I explained on the previous video, if you haven't watched it, please watch it. I say that completing the square is only one of the tools that you could use, but it's not the tool that's best for every question, right? It's like saying, here's a shovel, I want you to dig a hole. Oh, that's great. But here's a shovel, I want you to hammer in these nails. That's not the best tool to hammer in nails, right? So where am I trying to get at here? Completing the square is horrible for number 16, right? Imagine that. I'd have to take half of 3 and then square it. Forget that. What other method do you know? What other tools do you have of factoring to be able to solve this one? The GCF, right? I mean, think about that. There's an x in both of them. So if you pull out that x, you'll have an x plus 3 left over. And now we could do what we did a couple of sections ago with the zero product property. If you have something times something and it equals 0, well then that first something could be equal to 0 and the second something could be equal to 0, which means that you're going to get 2 answers after you solve both of them. This one's already solved for you, and this one, the answer is going to be -3. I mean, that's cake right there compared to completing the square method. I mean, completing the square method on number 16 right here is honestly like trying to hammer in some nails with a shovel. It's just the wrong tool for that job, okay? To be honest with you, I would not use completing the square on any of these that have a b value that's odd. Would I use completing the square right here? No. Heck no. Why not? Because when I try b divided by 2 and then squaring it, what's this? That's 1 divided by 2. That's 1/2. Squaring it 1/4. Who wants to deal with that? Nobody, right? Yep. So what's a better method to solve this guy? Factor, split, and solve. What times what is -6 that if you combine together is +1? Oh, that's +3 and -2. Oh, it's equal to 0. Okay, split them. And then solve, right? Wait a minute. Which ones were we supposed to do on this one? The even ones, huh? Yeah, even. I'm sorry. That was an odd one. Hey, but my point is, completing the square, I would only use, it's only a tool, and I would only use it if your b value is divisible by 2 and it works out nice. Oh yeah, but don't forget, completing the square, your a value has to be 1, right? So even on 20, if you're thinking, oh, I want to use completing the square right here because I could divide this by 2. Can't do that. First, you have to get rid of the 3. You got to make your a value 1 on completing the square. So that would be horrible because when you divide everything by 3, when you divide by 3, divide by 3, divide by 3, you're going to end up with x squared plus 2/3 x minus 1/3. So to complete the square, you'd have to get this b value, divide it by 2, and then square it. Forget that. What other method would we use? Might as well just jump back to the original, and what other method would you use to factor, split, and solve this? I just showed you guys a shortcut, right? To factoring quadratic trinomials when the a value is not 1. Well, you might as well use that. Step 1 is to multiply a times c. A is 3, so let's scratch this out. A is 3, c is -1, a times c is -3. Step 2, think of the multiples of negative 3 that combine together to give you the middle value b, which happens to be 2. So that's really just a negative 1 times 3. That's it. That's the only pair of numbers that works. This is the right combo. Now, instead of changing 3 terms to 4 terms and factoring by grouping, we learned that shortcut. You put in your factored form answer format with the AX right here. What is A? 3. AX right there and there. And I put the pair of numbers from step 2 right in there. And of course, this is still equal to 0. And of course, I need the magical step, step 4, is to reduce each of those binomials. So the first binomial cannot be reduced at all, right? So I just leave it. Or you could reduce by 1, but it's going to stay the same. The second one I could reduce by what? By 3, so it'll just become an x plus 1. So I now have it factored, and I now am able to split it and solve. So when I split it, 3x minus 1 equals 0. X plus 1 equals 0. Solve them. We have a plus 1, 3x equals 1. Divide by 3, x equals 1/3. That's one answer. Minus 1, x equals negative 1. That's another answer. So again, I would not use completing the square on this one. So again, completing the square is only a tool. You get to choose when to use it. Even though right here it says use it on all of them, that's a horrible idea. Let's not do that. I would only use it on which ones? Which ones would you use it on? 24 and 18. Completing the square on 18, completing the square on 24, and that's about it. Would anybody like me to do one of those? 18? Okay, so let's actually do completing the square here. Step 1 is to make sure your A value is 1 and that you make space for your new C value. So let's add 13 to both sides. I'm not going to show my work so I could save space. It's just going to be x squared minus 4x space equals plus 13 because I added 13 to both sides, right? Or do you want me to show my work? I'll do it. Plus 13, plus 13. Okay, now you take half of b, which is negative 2, and then square it. It takes you back to a positive 4. And what you do to one side, you must do to the other. So if you added 4 there, you have to add 4 over here. This right here is a perfect square quadratic trinomial, which means that it could be factored into a binomial squared. So let's skip a step, jump right to a binomial squared, put the x right there, and what belongs right here? Half of b. What's half of negative 4? Negative 2 equals 17. Apply a square root, apply a square root. X minus 2 equals plus or minus the square root of 17, which cannot be simplified. It's already simple. So your final answer will be x equals, if you add 2 here and add 2 there, just rewrite it, positive 2 plus or minus square root of 17. That's the answer, number 18. What do you think? So definitely completing the square is a good tool to use when you could use it. But most of these, it's not a good tool to use. Right here. Man, this one's like, if I tell you to complete the square on this one, that's like saying like, hey, cut this piece of paper with this shovel. It's just not good at all, right? What's the best method here? Just square root both sides. Boom, boom. X equals what? Plus or minus, yeah, don't forget. And what's the final answer? I square root 11. What? I mean, if you do complete the square on that one, that's just absurd. That's ridiculous, right? So we have all these tools to solve equations. Use the best tools, right? Again, 24 for sure will be completing the square, a good method. Okay. Now so whenever you have a b value that's divisible by 2, like 24, and your a value is 1, that's great for completing the square. But there are some, like number 22, is a b value divisible by 2? No. Okay. So completing the square wouldn't work out that nicely. So of course, try to do something else. Like try to do the parenthesis x. But what times what is negative 3 that if I combine together is negative 1? It doesn't work, huh? So you can't factor with this method. So we're really stuck. You can't really it's not factorable. So right here, there is no other option. You have to use completing the square, and it's going to be ugly. Why is it going to be ugly? Because you're going to end up with a fraction as a b value, right? I mean, as your perfect c value. So your a value is 1, your b value is -1, your c value is -3. Before calculating that perfect c value, let's make space for the c value, right? Step 1 on completing the square is to make sure your a value is 1 and make some space for your c value. So let's get rid of that -3 by going +3, canceling it, +3. Here's our new ready equation with the space for our new perfect c value that we're about to come up with. And of course, put space on that side as well because you have to add it to both sides. So what is our perfect c value? It's going to be b divided by 2 and then multiplied with itself. So our b value is -1. So I really have -1 divided by 2 and then multiplied with itself. So what is -1/2 times -1/2? +1/4. Yay? That is our perfect c value, +1/4. And when you do to one side, you must do to the other side, +1/4. Now that it's a perfect square quadratic trinomial, yeah, it's ugly, it has fractions, who cares? Why? Because I know that that perfect square quadratic trinomial could be written as a binomial squared. So I have an x right here, and what belongs in here? Simply half of this, right? A minus, half of 1 is 1/2, so -1/2 right in there. And we still have it equal to, what is 3 plus 1/4? That's 3 1/4. Yes? Now, why would we want to complete the square to get a binomial squared? So we could apply what? A square root. But before applying a square root to both sides, let's change this mixed number into an improper fraction. What's 4 times 3? +1. So I'm going to rewrite the right side of my equation as 13/4. And of course, I'm going to rewrite that binomial squared. So now I could solve this by applying a square root. So square root, x minus 1/2, no more square or square root, equals plus or minus. And when you have a fraction inside a root, you could split the root to the numerator and the denominator. Now, square root of 13, you can't do it, but the square root of 4, you could actually do that. That becomes 2, right? So what we really have is plus or minus a fraction with the square root of 13 on top and the nice, beautiful number 2 on the bottom. All I need to do now is get x by itself. So plus 1/2 and plus 1/2. And of course, your answer will be x equals, all you do is write this one first and then your plus or minus second. So you have 1/2 plus or minus square root of 13 over 2. That is the correct answer right there. Now, because you really do have a fraction plus or minus another fraction with that common denominator, you could actually put both numerators together over one single denominator of 2. And that's what they do in the back of the book. I accept this answer the way it is, but the answers, the solutions on the back page of your worksheet, it's going to have it as 1 plus or minus square root of 13 over 2. Either one's correct. All right, so we're done. Well, I'm done with this long video. You have a couple more problems to do. We're supposed to do the odd ones, I think, or the even ones. Even ones, yeah. So you still need to do 24, which you could do by completing the square. And if you finish this entire worksheet, you could then move on and do the next homework assignment, which is going to be from the book, still the same section, 4.5, page 260, numbers 9, 12, 19, 30, 32, 33, 39, 40, 41. It sounds like a lot of work, but it's not. And like I said, most of the time, completing the square is not the best option. I picked a bunch of questions where completing the square works out, and you even end up with imaginary values, so we don't lose touch of i's. But there are a couple that you could solve by factoring a lot easier with other factoring methods, with other tools. But the majority of these, completing the square works out pretty great. So you could get a book right now if you already finished the worksheet, and let's work on these questions. If you want to check your answers as you go, I do have the answers posted on the wall. So here are the answers posted on the wall. This is what I expect to see in your notebook. You guys copying down the equation itself, showing the completing the square method first by moving that c value over to the other side, having space for your new perfect c value, and all this work that I do here. So all the answers are right here. There are many roads to the same place. I do want you to practice completing the square, but like on 32, it's way easier to just factor, split, and solve. 33, it's way easier to just factor, split, and solve. So use your tools accordingly.